Hello everyone, welcome to our class on inequalities. Now we'll start with the concept of inequalities and let's start with notation. Understanding inequalities, we need to first understand the notation. The idea of notation can be well explained using the concept of number line. So let us consider the number line. So we have number line. Zero, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. Anyways, it could continue on both sides. 1, 2, 3, 4, 5, 6. 0 down towards the left. -1, -2, -3, -4, -5, -6. Now let's pick a point. Let's call it the reference point. Let's pick point 0. Let's call it a reference point. Now all points going towards the right of 0, they are definitely bigger than 0. So towards the right of 0, the values are increasing. So with respect to point 0, the reference point, any numbers towards the right is bigger than 0. So we can say, for instance, we can say 1 is bigger than 0. So 1 is bigger than 0 simply means 1 greater than 0. So we write it in notation form, 1 bigger than 0 can be written in notation form as 1 greater than 0. All values towards the right of 0 are definitely bigger than 0. Let's say we pick 3. Obviously 3 is also bigger than 0. Now all points towards the left are obviously less than 0. So means if you pick any point and you go down towards the left, we have it to be decreasing, or we say reducing. So if you pick a reference point, let's say -3 for instance, and you go down towards the left, all points going down towards the left are bigger than that point, and all points going towards the right, all points going down towards the left are less than that point, and all points going down towards the right are bigger than that point. Let's say for instance we pick a point -3. So that's the idea. So still on the notation, So with respect to point 0, going down, the numbers are reducing. So let's say we pick negative 5. So we can say negative 5 is less than 0. So automatically here we have the symbol for less than. And here we have the symbol for greater than. So that's the basic idea of the notation in inequalities. So the basic inequality notation less than, greater than, so here we have less than or equal to. So below the less than, when you have a little straight line below the less than, so it is called less than or equal to. So another notation is greater than or equal to. If you have a little straight line below the greater than, something like this, so we call that greater than or equal to. So there we have the idea of the notations in inequalities. So if we write, for instance, we can write a greater than b, a greater than or equals to b, alright, c less than d, c less than or equals to d. That's basically what we decide to write them that way, just to explain the concept of the notation. So let's look at some rules. Let's look at some rules in inequalities. Let's take some rules in inequalities. Now, what are some of the rules we consider in inequalities? Now, if a is greater than b, then we can write it as b is less than a. Also, if b, if let's say p is less than q, then we can write q is greater than p. Let's use numbers so we'll be able to understand what we're talking about. Let's say, for instance, 5 is greater than 2. Then if we swap the position, position wise, and we decide to bring 2 here. So we said 5 is greater than 2. So if we decide to start the narrative with 2, then obviously we can say 2 will be less than 5. So that's the idea of swapping. The same way, if 2 is less than 5, then if we decide to swap position wise, then the inequality also changes If 2 is less than 5, then 5 becomes greater than 2. So if A is greater than B, then B is less than A. One of the rules of inequality is also when we multiply or divide by a negative, inequality sign changes. It's a very important rule. Let's write it in words. Multiplying both sides or dividing both sides of an inequality changes the inequality sign. Let's say we have x, let's say we have negative x less than 3, and we need to get a value for x, so we need to get rid of this negative sign, and we have multiply both sides by -1. So if I have to multiply both sides by -1, so we have negative x times -1, that's the left side, right side 3 times -1. Now the rule is once we are multiplying both sides of the inequality by a negative sign, the inequality sign must change. So here we have less than, so we need to change to what? Greater than. It's a rule, provided you have multiplied both sides of the inequality by a negative. So inequality changes to greater than, and we now have a situation whereby x minus 1 times, okay, this obviously times, so multiplying both sides by -1, minus x times -1, 3 times -1. The inequality changes from less than to greater than. Definitely all this we'll see while solving questions, but it's important to explain them. So minus x times -1 obviously becomes x. Then we have greater than 3 times -1, -3. We can have a situation in that manner. Let's take, if we have another situation, let's say we have a situation in which we have minus x less than or equals to -3, and we need to get a value for x. When solving equations like minus x equal to -3, in equations we don't have the inequality sign. Equations just contain only equal to sign. We are permitted to say minus cancels out on both sides, and we have x equals to 3. But it is wrong to do that in inequality. So because there's an inequality sign here, which is a less than or equal to, it will be wrong for us to say minus cancel minus on both sides. So that's very wrong in inequalities. So the best thing to do is to say, multiply both sides by -1. Multiply both sides by -1. Similar result, similar effect takes place when we say we divide both sides by -1. So multiply both sides by -1, we have negative x times -1. Okay, we now have -3 times -1. Now the rule says the inequality sign must change when we multiply both sides by a negative or divide both sides by negative. So the less than or equal to strictly becomes greater than or equal to. Very important. Now from there we'll have a situation like minus x times -1 becomes x, greater than or equal to -3 times -1 becomes 3. So that will be the answer to that. So those are some of the rules of inequalities. There could be several rules. We'll see them as we proceed solving questions. Let's look at some questions on linear inequalities involving one variable. Linear inequalities involving one variable. So solving linear inequalities involving one variable. Let's take the following question. Let us find the solution set of the following inequalities, and possibly let's represent the answer on a number line. Okay, we have, so we'll take the one and we'll solve them. 2x minus 3 is less than x plus 7. Let us provide the solution. Best to collect like terms. Similar way we solve equations, just to strictly follow some inequality rules. X and x comes together, so we have 2x. This is plus x to the left, turns to minus x. Similar equation rule. Less than, this is plus 7. Then negative 3 comes to the right, turns to plus 3. So 2x minus x obviously is x less than 7 plus 3, 10. X less than 10. So let's have the number line. Number line is like a simple graphical representation or a graphical illustration. 0 is a very important reference point. The number is a positive number, 10. So all positive numbers are basically to the right of the number line. So we have 10. Let's put it anywhere. It's not drawn to scale. So numbers less than 10. S is obviously less than 10. So less than 10, coming towards the right, we are increasing. So that's greater than 10. So we won't have that. Less than 10 will come down. So that's a number line for x less than 10. We are done with that. Let's take another one. Let's call it number 2. We have 3x plus 4 greater than 1 minus 2x. The same way we tend to collect like terms so that all x are to one side of the equation. Then plus 4 comes to the right. So we have 3x plus 2x greater than 1. Plus 4 comes to the right, turns to negative 4. Moving from left to right changes sign anyways. 3x plus 2x, that's 5x greater than 1 minus 4 is minus 3. 5x greater than minus 3. So when 5x is greater than minus 3, we need to get a value for x. So in order to get a value for x, we need to remove the 5. So let's say divide both sides by 5. Here we are dividing both sides by a positive number, so it doesn't affect the inequality sign. Hence we have 5x divided by 5 greater than minus 3 divided by 5. 5 cancels 5, x greater than minus 3 over 5. So let's try to have a number line representation of that. Reference point 0. Minus 3 over 5 is a negative number, so negative numbers are to the left hand side of 0. Okay, so we have that. We're not drawing to scale, so let's put minus 3 over 5 anywhere towards the left hand side of 0. And we have s greater than minus 3 over 5. So numbers greater than minus 3 over 5 will come towards the right of minus 3 over 5. So here we have s bigger than minus 3 over 5, and that's the number line representation. So we call this number line. Okay, we have another one. Let's call that number 3. 1 over 3x minus 2 less than or equals to 2 over 5 of x plus 1 over 4. Okay, so this involves fractions, so we could think of way of clearing the fractions. So denominators of the fractions are 3, 5, and 4. So we can tend to find the LCM of 3, 5, and 4. So LCM of 3, 5, and 4. Let's say 3 here, 1, we still write 5, we still write 4. So 4, then we have 5. So the LCM is 60. So in order to clear the fraction, we'll multiply each of the terms by the LCM, which is 60. So let's multiply through by 60, a positive number that doesn't change the inequality sign. Multiply through by 60. So multiplying through by 60, what do we have? We have the first one, 1 over 3 of x, multiply 60. The second term, 2, multiply 60, less than or equals to 2 over 5 of x, multiply 60, plus 1 over 4, multiply 60. By doing this way, the fraction will be cleared. 3 here 1, 3 in 60 is 20, 5 here 1, 5 in 60 is 12, 4 here 1, 4 in 60 is 15. Now we have 20 times x, that's 20x, minus 2 times 60, 120, less than or equals to 2x times 12, that's 24x, plus 15 times 1, 15. Now we have a simple linear equation. So collect like terms. So we can transfer 20x. We have minus 24x less than or equals to 15 plus 120. Like this, like this. Both do not contain x, while both contains x. So try to bring them together. And once there's a cross of the inequality sign, obviously the sign changes. So positive 24 comes to the left, negative 24. Minus 120 comes to the right, turns to positive 120. So 20x minus 24x, that's negative 4x, less than or equals to 120 plus 15, that's 135. So x is obviously less than or equals to, no, so we have negative 4x, so we need to divide both sides by minus 4. Let's say divide both sides by minus 4, or we say multiply both sides by minus 1 first, then later we get what we want. But the aim is to remove this negative 4 behind the x. So let's say divide both sides by minus 4. Divide both sides by minus 4. We have minus 4x divided by minus 4. Remember, inequality sign changes since we are dividing both sides by a negative number. So the inequality sign, which was less than or equals to, obviously we change to, from less than or equals to, we obviously change to greater than or equals to. Let's take note of that, very important. Since we are dividing both sides with a negative number. Okay, so minus 4 cancels minus 4. Now we write x greater than or equals to 135 over minus 4. So very appropriate, the minus can be written up. So x greater than or equals to minus 135 over 4. X is greater than or equals to minus 135 over 4. Let's show you a number line representation of that. Let's say this is 0.0. Minus 135 over 4 is a negative number, so it comes to the left of the number line. Comes to the left of 0. Since 0 is a reference point, minus 135 over 4. So we'll put something like a small circle on 135 over 4. Now numbers greater than 135 over 4 comes to the right of the number line. So numbers greater than 135 over 4 comes to the right. So s greater than minus 135 over 4. Okay, but there's also equal to there. Not just s greater than 135 over 4, but s can also be equal to 135 over 4. So since we have greater than or equal to, on minus 135 over 4, we need to shade the small circle here. The purpose of that is to show that that point, minus 135 over 4, is also included. So s is not just greater than or equal to minus 135 over 4, it's also equal to minus 135 over 4. Let's take one more. 4. We want to solve the inequality 4x plus 1 over 3 greater than or equal to 2 over 3 of x minus 2. Obviously, it's an equation that also involves fraction. So we have 3 and 3 to be the denominators. So LCM of 3 and 3 is 3, so we'll multiply through by 3. Inequality sign doesn't change. So multiplying through by 3, we have 4x. Each of the terms will be multiplied by 3 plus 1 over 3 multiplies 3 greater than or equals to 2 over 3 of x multiplies 3 minus 2 multiplies 3. That becomes 12x plus 3 up cancels 3 down, so we have plus 1. That's 12x plus 1 greater than or equals to, also we can say 3 cancels out, up, down, greater than or equals to 2x minus 6. So let's do some collection of lifetimes. Plus 1 comes to the right, negative 6 comes to the left. That's wrong. Not all numbers to the right, all variables to the left. So 2x comes here. So we have 12x. That's plus 2x comes to the left, turns to minus 2x. Greater than or equals to minus 6. Plus 1 comes to the right, turns to minus 1. So 12x minus 2x, that's obviously 10x. Greater than or equals to minus 6 minus 1 is minus 7. Let's divide both sides by because we need to get a value for x. So the coefficient of x is 10, so x can stand alone. Let's divide both sides by 10. Here 10 is a positive number, so inequality sign doesn't change. Let's divide both sides by 10. So we have 10x divided by 10 greater than or equals to negative 7 divided by 10. 10 cancels out. S becomes greater than or equals to negative 7 over 10. So let's have a number line representation of that. So we have 0. Negative 7 over 10 is a negative number, so that's to the left of 0. Minus 7 over 10. Let's draw a small point there. Then s is greater than, so numbers greater than minus 7 over 10 comes towards the right of minus 7 over 10. All numbers greater than it comes towards its right. So s is greater than or equals to minus 7 over 10. Now because of the presence of equals to, the point minus 7 over 10 is also included, so that circle will be shaded. So that's the idea. Now let's look at some cases where we have combined inequality. So as a case where we have combined inequality. Okay, find the solution set. Question. Definitely a question will explain that better. Find the solution set of the inequality three x minus 2 less than x plus 1 less than or equals to 2x plus 3. Okay, solution. So let's consider the solution. We have 3x minus 2 less than x plus 1, and x plus 1 is obviously less than or equal to 2x plus 3. So we could combine the first two. Let's combine the first one and try to solve that. So we have 3x minus 2 less than x plus 1 collect like terms, so we have 3x minus x less than 1 plus 2. 3x minus x is 2x less than 1 plus 2 is 3. Let's divide through by 2, x less than 3 over 2. Okay, done with that. Still want to make reference to this. Let's pick the last two. Since we have a connective joined inequality, combined inequality, so we can pick the last two. Then we'll try to solve this. Here we have, now bear in mind we need to keep this answer, one of the solution. Now we have x plus 1 less than or equals to 2x plus 3. Let's try to solve that. providing that we have x plus 1 less than or equal to 2x plus 3. So we have collecting like terms x minus 2x less than or equal to 3 minus 1. Okay, that's right. X minus 2x less than or equal to 3 minus 1. Okay, x minus 2x, that's like saying 1x. So 1 minus 2, that's minus 1x less than or equal to 3 minus 1 is 2. Okay, so this can now be removed. Minus 1x less than or equals to 2. So let's decide to multiply both sides by minus 1. Minus 1x times minus 1, that becomes 1x. Or let's say simply x. 1x is just the same thing as x. Multiply 2 by minus 1, that's minus 2. So we have multiplied both sides by negative. So less than or equals to change to greater than or equals to. Now we also have this. Now let's see how the answers will go. Let's see how the answers can be combined. So the answers can be combined by considering a single number line and observing their orientation on a single number line. So let's observe their orientation on a single number line. This is reference point 0, negative 2 towards the left, 3 over 2 is a positive number, obviously, towards the right of 0. S less than 3 over 2. So S less than 3 over 2, numbers less than 3 over 2. Let's have this point. Numbers less than 3 over 2 definitely comes this way. Keep going down. So let's say S less than 3 over 2 shaded, let's say. Numbers less than 3 over 2, obviously going that way. S is greater than or equals to minus 2. So there's an equal to minus 2 here. So because of the equals to we shade. So numbers greater than or equals to minus 2. Numbers greater than or equals to. Numbers greater than minus 2 are going towards the right, obviously. So numbers greater than minus 2, let's shade with a different orientation. Now that means the shadings agree at a point. The shadings agree in between. There's an agreement here. So that means the inequality can be merged, or the final answer can be merged as a single answer. Can merge it as a single answer, which looks like final answer. If there's no agreement, the final answer will be written separately. But here there's an agreement, so we can have a merging of the answer as, or what we call the solution set. Start from the smaller number, minus 2, less than or equals to, because of this shaded part, x. Then x is just less than 3 over 2. So obviously we can see that s is less than 3 over 2. It's an agreement. S less than 3 over 2. And negative 2 is less than or equals to x. Negative 2 less than or equals to x simply means s is bigger than or equals to minus 2. So final acceptable answer for this question is minus 2 less than or equals to x, x less than 3 over 2. Okay, what about a question in a case where we'll not be able to merge the answer in this way? We'll see it as we solve more example. But I can easily throw more light on that. Let's say we solve and our final answer looks like s less than, let's say s less than minus 3, and we also have another answer that looks like s greater than minus 1. Okay, let's see how this look like. Still on a single inequality, we have reference point 0, negative 1 to the left of 0, negative 3 also to the left of 0. S less than minus 3, numbers less than minus 3 go this way. Now s greater than minus 1, numbers greater than minus 1 will obviously come towards the right, greater. Now you see, if we decide to shade s less than minus 3, let's say this way, And if you decide to shade s greater than minus 1, s greater than minus 1, let's say we decide to give it a different orientation, s greater than minus 1, and we decide to shade this way, you will observe that the shadings do not meet. So there's no agreement, do not meet. So the answers will not be merged at the single inequality. So final solution set, or what we say our answer, will just be the way it is, from the smaller one then to the bigger one. Separately, s less than minus 3 goes down the way it is. Then we will have s bigger than minus 1 goes up the way it is. Then we have our solution set. So that's the answer to that. So in my next lesson, we'll look at how to solve quadratic inequalities and some other concepts. Thank you for listening. I'll see you in my next lesson. Bye.